Hello, let's continue our Sudoku adventure with Intersections Sudoku by Gene. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these intersection clues here. That's these squares with a number inside. Each of these squares has 4 diagonal directions. There's this way, there's this way, there's this way, and there's this way. I don't know why I chose that order. But at least 2 of those diagonal directions must sum to that value. So maybe this sums to 14 and that sums to 14. This could also sum to 14, but we just need at least 2 of them to do that. So you just take the diagonal and go to the edge of the grid. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, the 4 draws my eye, because this diagonal cannot add to 4. The minimum here would be a 1-2 pair because of the box. Minimum here would be a 1-2 pair. That adds to 6. So this is not the diagonal. Now, this diagonal and this diagonal would have to be a singular 4. But we can't do both of them because that would share a 4 in the column, which means that this diagonal is definitely used, and it's a 1-3 pair. So, and then we have a 4 definitely in one of these two, and I don't really like this corner mark, but I kind of want to do that anyway. Okay, 15 is not using this diagonal, and it is not using this diagonal. So this adds to 15, and this adds to 15. This is already 1 or 3. 15 and 3 is not all that restrictive, though. Then the 14 is just 3 in each direction, so we can't really tell right now. But let's say this was a 1. These would add to 14. That still seems completely viable. Well, hold on. You know, actually, 14 is not viable in 2 digits. 6 is our max. 12 is the max here. So if this max is at 12, right, okay. Sorry. 6 is our max digit. This has to be double 6 with a 3 here to get to 15. That's the only way to do it. So that one's fulfilled. And so this is a 1 then. Now, what does that mean for this guy? Since these can't be 6, these max out at 5. So we actually have to do 5, 5, 5. I think that's the only way. We could do 5, 4, 6. Hold on. Yeah, we could do 5, 4, 6. But this is a 5 or a 6. Wait, yeah. This maxes out at 5, so this is minimum 5 to get us to 15. And then so it can also be a 6. And so these are from 4 or 5 is I guess the key there. And at least one of them is a 5. We can't do 4, 4. That's too low. Now how about 14 then? So none of these are 6. 5, 5, 5 would be 15. So we got to be 4s and 5s here as well. Well, no, but we don't know that this way actually it does. We don't know that this way adds to 14. Hold on. Well, with this 1, I don't think this way can add to 14. These would have to add to 13, and 12 is the max. But actually, it's not even 12 because this can't be 6. 6 is one of these two. So it's not this diagonal. This diagonal is not adding to 14. This diagonal, I think, could. We could do like 5, 5, 4. Well, we have to be a little careful, though, because we know one of these is a 5. So if I did 5, 5 here, that would force this to be 4, 4. So one of these would be 5, but not this one. In fact, this one maxes at 4. Let's just write 1, 2, 3, 4 here, because it's not a 6, and one of these is a 5, and it's going to see this one. So this maxes at 4. And so if it was a 4... Oh, no, we can't do double 5 up here. So actually, I don't think this can be the 14. This maxes at 9, and so this would have to be a 5, but it can't be because one of these is a 5. Okay, that's great. And so this also isn't. And so this adds to 14, and this adds to 14. Okay. And that's it for our constraints. So how do we make this add to 14? We know this also maxes at 4. Oopsie. This maxes at 4. If it was a 4, this would be 5, 5, 5. Now, what does this max at? What can I say? This cannot be 5. This can't be 6, and it can't be 5 because one of these is 5, right? So this is also 1, 2, 3, 4. So these max at 8. We need to get to 14. That would be a 6. So this has to be 6. This has to be 6, 4, 4. That's our only option. That makes this 5, 5, 5. So we can get rid of these highlights. That's not a 4. In fact, we're down to 1, 2, 3. That's not a 3. And then these add to 14. None of them are 5s. This max is at 4. Actually, it can't even be a 4. Remember, 4 is up there. This is 1, 2, 3. So we're going to have to use a 6, right? This is max 3, which means this is minimum 11. But 5 can't be used. So without the 5, our max, if unless we did double 6, if we don't want to do double 6, which is 12, our maximum is, oh, these can't even be 4. So our maximum would be 9, which is no good. Okay, so this is just double 6, adding to 12. And then this is a 2 to make up the 14. That does put us to 6 there. And now it should be Sudoku from here because I don't think I have any more of these to fulfill. All right. So these are from 1, 2, 3. That's not a 2. So that is our 2. This is a 1, 3 pair. This 3 tells us the order. That's 1, that's 3. So this has to be the 4. Okay. This is from 1, 2, 3. Not at the 2. So the 2 is placed there. That gives us the 1, the 3, and the 1. All right. And then these two, oh no, sorry. Yeah, these are from 1, 2, 3 as well. So this has to be the 1. This is the 2. And this is the 3. That's our 1. Up here we need 3, 4, 5. So this has to be the... No, it doesn't. So this is 4 or 5. Let me just write out 3, 4, 5. In fact, these two 3s look in. So this is our 3. And then this can't be 5. So that's 4. That's 5. That places the 4 here for this 4 to work. And then this digit is a 5 for the column, and this digit's a 2 for the column. Up here we need a 2 and a 4. So that's 2 and that's 4. And then down here we need a 3 and a 5. So that's 3 and that's 5. All right. Neat puzzle, Gene. I enjoyed that. Yeah, this was interesting. The way that these 14s and 15s got, like, the interaction between this 14 and 15 was very nice. That's basically the best I can say that. All right, well, how'd you do?